this way. Right, okay, so there was a couple of points on this question. You had to read the question. So for the first question it said 8-bit number. So all your answers had to have 8 bits. If you wrote them incorrectly, so there were a few people wrote A, which was right 15. Few people did that. That is technically 15 in binary, but that is not 8 bits. So you have to pad it like that. Okay? Now I wrote the question like that, but I said at the top of the question that that meant that was a number 15 in decimal, which is important, because if I wrote down, I'm going to pay you that an hour. If I gave you a contract and I said, I'm going to pay you 1,000, well, I'm not going to tell you what, I'm not going to utter it, I'm saying, that's the figure I'm thinking of, what do you think to that for an hour? And you all go, yes. And then I go, yeah, it's in binary. No, sorry about that. Slight difference, because that would be 8 rather than 1,000. Okay? If that was base 16, it'd be even bigger number. Because the column headings in hexadecimal go like that. I wouldn't mind being paid that an hour. It'd be very interesting actually if you could find some crazy lawyer to argue that you weren't explicitly told you were being paid in decimal and that you thought it was hexadecimal when you signed the contract. Could do that maybe. You'd have to get a crazy lawyer, although there's plenty of them. Looking at that. Right. So it's super important. So the one question that was the pain for everybody was 256. So the number 256 in 8 bits is impossible. What's the range?
255.
Yeah. Not to if we're talking unsigned numbers, which is what we were for this, it's 0 to 255. So you can't actually do 256. No matter how much you want to, you can't do it. So you can say, I would need 9 bits if you want to be super technical about it. Okay. Right, okay, the next one, convert hex. Well, there was a variety of numbers that needed converting to hexadecimal. Okay, so you had something like this, 800, and it was a number in hex. Now, unless you're going to put the column headings, we haven't got a calculator, so it makes it quite tricky. The column headings would be that. 8 256s. Okay? So, I could try and do it in my head and make a real mess of it, or I could just convert it to binary. So if I converted that to binary, each one of these is 4 bits, remember. And we don't do it that way around, Lauren. Alright. So write down what 8 is. So 8 looks like that. And then you've got do, and do. I don't know why I'm doing the sound effects, but there you go. Right, so these are the column headings. There's no bits there, so, well, there is, but they're 0, so they're insignificant for what we're doing. Oh, keep going. The nice thing about binary is you just keep doubling up. So it's not hard, as long as you can keep multiplying by 2. Which luckily I can do, so I don't look totally stupid when I'm doing this. So it is, 2048 as a decimal number. So I've actually written it down 3 times. The exercise was there to give you a bit of testing, so you could do your conversions. There was another hex one, FF, and again it was 16. So all you have to do was write that in binary, which is 1111, and again, and actually, you don't really need to put the column ends on to work it out. What's a quick way of working out what that number is? Go for the next column heading, because it's 1 less than that. Okay, you've got all filled in. So it is 255, that one. Quite a lot of people got that one right, but some of them to pieces. And then there was one that was in binary that a few people didn't do, which I found a bit weird. Although I haven't got my glasses on, so I'm going to read this wrong probably. It had a little 2, which meant it was base 2, binary. Okay, so all I've got to do is whack my column heading straight on. Okay, so it's horrible numbers for me to add up. But using my Tetris system, I can see that 512 and 128 go together quite nice. So that's 510 plus 130, which is what I do. I start messing up with the numbers. So that's 640. And then we've got another 256. So that's 856. Then we've got 32 is a whole number. I'm going to add the 2 on, so I've lost count now. I'm going to make 8, what did I say? 856. 856. 32 and 8 go nice together, that's 40, so that'll make me 8, 9, 6. You won't get anything as bad as this in the exam. So I've done all that lot, I've done that and that. I've done that. So I just need to add the 16 on, which is a horrible number to add on, so it's got to be a 2 at the end. It's probably going to be 912. Okay. So it is just a matter, you've got to read the question. Right, the next ones convert to binary. Again, they were just hex, most of them. So you had something like 1715, but it had the little 16, and we just wanted it in binary, as many bits as you want. So you could do this 2 ways. If you're going to go for as many bits as you want, the easiest way is to start from that right hand edge. So I go, what is 5? It's a hex digit, so 5 in binary is 1010. 1 is a nice easy one. 7 is 1110, and then 1 is 1000. But you could have just written it like that. Okay. So it's just a matter of doing the conversions. The last ones were to write numbers in hex. So one that a few people had struggled with was 256, which we just knew was this. We just written that the other way, so it was on the previous question. So we had that. Now I've written it with gaps. A few people on the homework was writing numbers like this because they'd gone and organised it from the other side. Use the least significant bit and group in 4s from that side. If you do it like that, that is still correct, and I've got no problem with that, apart from it's really evil to work the answer out. Evil is not good. We should all know that. Evil is not good. Okay, but doubly so if you've written your binary in an evil format. The examiner will be given cause to either add this up wrong. They've got to check your answer. So in their mark scheme, they might have something like this. That is so much hard. It's hard to compare. Okay? Very hard to compare. With the hex ones, I just like read the question and did them in my head while I was reading what you were doing. But the examiner's not likely to do that. They're more likely to just read off the mark scheme. So if that's what the mark scheme looks like and you presented it like that, you're asking for an examiner to go, oh, it's not the same. And we don't want to do that. That's why people have things remarked, because they didn't get marked properly in the first place. You know? And I have had students' marks go up considerably. Like 9 marks on a 120 mark paper. Which made a student go from getting a B to getting an A. Which got him into his university he wanted to get to. You know, we don't want to do that. Presentation's critical. Okay. Right. I'll just quickly do the homework one, which was the exam question. Like I say, I'm always going to try and give you an exam question. You'll see in a minute that I've put this on the system in a certain way. Just make sure we don't run out. No, I've got enough time. Right. 95. Using 8 bits. Okay. Plus 95. So I'm gonna, because I'm not gonna try and guess, I'm gonna put column headings. One thing I will say, there was a few people did this. Now, it wasn't just you, Lon, there's a few people. Right, I've got no problem. You did that, so obviously it lines up and it makes it easy. That's fine, but we don't write binary like that. Just as, like, if I'm getting paid £2.56 an hour, which is what it feels like sometimes, I don't have that written in like tabular format. I don't know how the examiner will react to an answer presented like that. That's what I'm saying. So I don't mind you doing working out like that, but if you do a final answer, what you could have done at the side, you could have just written it out again.
It's only that side that I actually don't have.
I know you
that
did.
Side I just like.
You went.
Squared them.
Yeah, I'm going to say the presentation was better on the other side. It's really important. You're going to moan at me because now you're going to picky get you doing the presentation matters. Yeah, it does. At the end of the day, remember, it's a game. Exams are a game. A game that could destroy or enlighten your lives. Okay, but it is a game, and we've got to play the game. So anything that we know about the game that gives us an advantage, like writing stuff neat, we do. Whether we grumble about it at the time or not. When I did maths at school, and this was what a superb maths teacher, she took a whole class of kids in a year, she got everybody through the O-level exam with an A. In 1 year, the whole class. And she would mark our work if we didn't have I think it was a 2.5 centimetre margin on the page, she wouldn't mark our work. We had to put marks at the top of the page. It was non-margined paper. I mean, it's draw a line. It had to be straight. Okay? And you think, are you crazy? I think you're crazy. You're a crazy woman. Why are you making us do that? You had to. Your final answer had to have 2 lines underneath it. So if your answer was that, they had to be the same length. And they weren't allowed to be like that. They had to be parallel. If you didn't do it, she would say, I cannot find your answer, and give you 0. And I used to think she was totally crazy, totally nuts. I don't know what she was talking about. But actually what she was doing is she was putting discipline in there. Okay? Because she knew that we're making it easy. We want to make it easy for the examiner. Everything we do. We want to say to the examiner, yeah, there's the answer, mate. Don't worry about all the crap. That's the answer. Yours was like that. I was like right hunting on some of your bits. And it was like, whoa! And there was hunting on some, because you kept changing the format. All right? It's all about consistency. That's what I want to see from it. I don't expect you to get it right from the start. Nobody got 0, which is a good thing. Okay? Yeah, so when we're doing these questions, I think, just for sanity's sake, put your column ends on. Don't put 24 as a column end, because that would be the most insane column heading. I started counting up in 8s for some reason then. That's why I did that. It's a nice number, 8. Why not count up in 8? But it doesn't help with binary. Right, so the first question said write 95. So we can have a 64. And then, actually, what I tend to do when I'm looking at these questions, I'll say, right, what happens if I add 32 to that? Oh, I get 96. Ooh, that's quite close. They pick that number on purpose to make it easy for you. So you say, it's 1 less than 32. So that must be all the others filled in, because that adds up to 31. Okay? So you've just got to keep it sensible. He said 8 bits, so we have to fill in the first bit. Then we had to write that in hexadecimal. So they're just testing that you can do the groupings, that you know there's a relationship between binary and hexadecimal. That is, every 4 bits is a hex digit. So that one is F, that one's 5. Then they said write it down in 2's complement. Now this is interesting. They got you to write the 2's complement before the sign of magnitude. Where it doesn't say anywhere on that piece of paper, you must answer BI before B2. Does it? It doesn't. You answer these questions in whatever order you want. So I would, as soon as I saw that, I'd go, I've got to write down plus 36, so I might as well do the sign of magnitude one first, and then I'll know what 36 looks like. So for that one, I'd leave my column headings up. I'm going to write down negative 36, so I'm going to put a 1, so I'm doing B2. Then I'm going to write down 36, which is obviously 32 and 4. A number of people wrote that as the answer, which is not 36, it's 38. And then use that answer for both. Right, so that is in S&M minus 36. To do it in 2's complement, what we'll do is we'll write plus 36 and then do 2's complement. And that will give us the negative. So I'm going to say positive, there's the number, it's already worked out for me. Then I'm going to do flip and add. So I'm just going to go flip, flip, not Philip, flip, flip, flip. Last one, keep everything else the same. So that is minus 32, 2's complement. Okay? It's practice. It's practice till it's second nature. And we'll do tons of practice on this. Okay? Right, can you all go on the computers? I'll upload that to YouTube if I can get my password right, so I can stop it recording. I'm going to lock it out.